All right, let's take a journey. We're heading out to the very edge of our cosmic neighborhood, to a place so unbelievably vast and distant that no one has ever actually seen it. We're going to explore the Oort Cloud, the mysterious, invisible boundary of our entire solar system. So, let's start with a question that gets right to the heart of it. We've all seen those incredible pictures of comets, right? These spectacular icy visitors lighting up our skies. But have you ever stopped to think about where they actually come from? Especially the ones that take thousands or even millions of years just to make one trip around the sun. The answer, it turns out, leads us to one of the biggest and most elusive structures you can imagine. Before we can really grasp what's at the very edge, we need a good map of our home turf. So let's do a quick tour, starting right here at the sun and working our way out. Okay, so first you have the familiar inner planets, then you cross the asteroid belt. Past that, you've got the gas giants, the outer planets. Beyond Neptune, we hit the Kuiper belt. That's a huge ring of icy stuff where Pluto hangs out. And even further than that is the scattered disk, which is, well, an even more chaotic zone of icy bodies. For a long, long time, we figured that was pretty much the end of the line. But here's the catch. That map, as neat as it looks, is incomplete. There's a giant, absolutely crucial piece of the puzzle that's just missing. A piece that happens to solve a really old cosmic mystery. And that missing piece brings us right back to the comets, because our standard map of the solar system just can't explain where some of them are coming from. See, the whole thing gets really interesting when you realize there are two different kinds of comets. On one hand, you've got your short-period comets. They swing by the sun pretty regularly, in orbits under 200 years. We know where they come from, the Kuiper belt. And they orbit on a flat plane, more or less, just like the planets. But then you've got the long-period comets. Their orbits can last for millions of years. And here's the weird part. They don't stick to that flat plane at all. They come at us from literally every direction, from above, from below, from the sides, as if they're falling out of a giant sphere that surrounds us. So that begs a massive question, right? If these long-period comets aren't coming from the flat disk of the Kuiper belt, then where on Earth are they coming from? And this is where a Dutch astronomer named Jan Oort steps into the picture. It's 1950, and he's looking at the bizarre orbits of these comets and proposes a solution that is both incredibly elegant and mind-bogglingly huge. He came up with the idea of the Oort Cloud. And no, it's not a cloud of gas. He imagined this immense, theoretical shell made of literally trillions of icy objects, completely surrounding our solar system like a massive cosmic bubble. And because it's a sphere, that would perfectly explain why those long-period comets can come at us from any direction. And when I say immense, I'm not kidding. The Oort Cloud is thought to stretch out as far as 100,000 astronomical units from the sun. Now remember, 1 AU is the distance from the Earth to the sun. So 100,000 AU means the edge of the Oort Cloud is nearly halfway to the next closest star. It's just unimaginably big. So how did this colossal structure even get there? Well, the leading theory is that it's all leftovers from when our solar system was born. Back in those chaotic early days, the massive gravity of planets like Jupiter acted like a giant cosmic slingshot, just flinging countless icy chunks way, way out to the farthest reaches, where they all settled into this huge, stable, and very distant shell. Okay, I know what you're probably thinking. If this thing is so gigantic and holds trillions of objects, why can't we just point a telescope at it and take a picture? I mean, what's the actual evidence here? Well, the challenges are just enormous. These objects are so far away, so small, and they reflect almost zero sunlight, which makes them incredibly faint. Seriously, trying to spot one would be like trying to find a single piece of charcoal in the dark from thousands of miles away, while staring right into the blinding lights of countless distant stars and galaxies. It's basically impossible with our current tech. So, since we can't see it directly, at least not yet, scientists have to do the next best thing. They have to look for its influence. They have to listen for the gravitational whispers it sends our way from the deep dark. And here's a fantastic example. About 70,000 years ago, a star we call Schultz's star actually flew right past the outer edge of our Oort cloud. That little gravitational nudge from a passing star was probably enough to disturb some of those icy bodies, knocking them out of their stable orbits and sending them on a very, very long journey toward the inner solar system. It's totally possible that some of the comets we see today are here because of that stellar flyby that happened tens of thousands of years ago. But science never just sits still. Just when we were getting comfortable with this whole picture, a new discovery came along and added a really fascinating twist to the story. We spotted an object named 2I/Borisov, and as astronomers tracked its path, they confirmed it didn't come from our solar system at all. It was an interstellar tourist just passing through. This was huge because it proved that not every long-period object we see comes from our own Oort cloud. We have cosmic visitors from other star systems too. So with all this indirect proof and these new discoveries, what does the Oort cloud really represent? Let's zoom out one last time and think about what it all means. If you want a real sense of the scale here, just think about the Voyager 2 spacecraft. It was launched back in the 70s. It is the most distant thing humanity has ever created. And yet, after all these decades of traveling, it would still take centuries, hundreds of years, for it to even reach the inner edge of the Oort cloud. That frontier is almost beyond our comprehension. The Oort cloud is such a great example of how science often works. Think about it. We knew the Earth revolved around the sun based on math and indirect evidence long before we could ever send a rocket up to look back and prove it. The Oort cloud is the same. Our confidence in it comes from a mountain of really compelling indirect clues. So in the end, that's really what the Oort cloud is. It's the true final frontier of our solar system. It's the line in the sand where the sun's gravitational grip finally gives way to the vast, empty ocean of interstellar space. It is, for all intents and purposes, the wall around our cosmic home. And that kind of leaves us with one last incredible thought. The Oort cloud proves how much we can figure out about the universe, even things we can't see. But it's also a huge reminder of how much we still don't know. If a structure this massive can stay hidden in our own cosmic backyard, what other secrets are just waiting for us out there, at the very edge of everything we know?